Okay, hello everyone. Let us continue the third part of today's class. Okay, so we are talking about problem 57. What is the sigma algebra generated by f? Okay, solution. If f is a function from a set x to a set y, and B is a sigma algebra. Okay, we have introduced what is a sigma algebra, okay, earlier. Of subsets of Y, okay, then the sigma algebra generated by the function f, denoted by sigma of f, is the collection of all inverse images f inverse of S of the sets S in B. Okay, that is sigma of f is equal to f inverse of S. Okay, given S is in B. Okay, next let us see problem 58. What is a compact space? Okay, why do we need to know what is a compact space? Okay, let us search for it. Oh, okay, so let me search compact only. Okay, so here. Okay, so we can see that space capital theta that is compact. Okay, so we need to know what is a compact space. So solution, formally a topological space X. Okay, what is a topological space? Okay, I have introduced it before. Okay, if you forget, you can click on this hyperlink and the PDF file will jump to here. Problem 26. What is a topological space? Okay, and you can review the solution. Okay, let us go back to topological space. Okay, topological space. Okay, here. Okay, X is called compact if each of its open covers has a finite subcover. Okay, what is the meaning of this sentence? Okay, we explain it immediately. That is, X is compact if for every collection C of open subsets of X such that capital X is equal to the union of small x for all small x in C. There is a finite subcollection. That is F is a subset of C, or F is equal to C such that capital X is equal to union of small x for all small x in F. This is the compact space. We have seen this figure before. Excuse me. Okay, so next, problem 59. What is negative semi-definite? Okay, why do we need to know what is negative semi-definite? Okay, let me search this. Negative semi. Okay, this is enough. Okay, because we have seen negative semi-definite here. Okay, and here is the solution. Okay, let us see. Okay, it's the solution to problem 51. What is maximum likelihood estimation? Okay, so let us go back to the problem. Okay, what is negative semi-definite? Okay, solution an n by n symmetric real matrix M is said to be negative semi-definite or non-positive definite if X transpose times M times X is smaller than or equal to 0. Okay, please note that this 0 is not bold, so it is a scalar, not a vector or matrix. For all vector x in R to the power of n. Okay, do you remember what is the meaning of this symbol? Okay, so R to the power of n means the n-dimensional real vector space. Excuse me. Okay, formally, M is negative semi-definite if and only if X transpose times M times X is smaller than or equal to 0 for all X is in R to the power of n. Okay. Next, let us see problem 60. What is a concave function? Okay, why do we need to know what is a concave function? Okay, it is because, okay, let me search it. Concave. Okay, because we have seen concavity, okay, in this solution. Okay, the same solution which negative semi-definite is in. Okay, so this is the solution to the problem. What is the maximum likelihood estimation? Okay, so let us see problem 60. What is a concave function? Solution: a real valued function f on an interval, or more generally, a convex set. Okay, what is a convex set? Okay, you can click it. Okay, and you will find we have introduced it before in problem 6. Okay, what is a convex set? Okay, so let us go back to the place. Okay, convex set. Convex set. Oh, I think we can search for concave function. It is faster. Okay. So a convex set in vector space. Okay, I think you have already learned what is a vector space when you took the course linear algebra. So I do not plan to introduce this here. Okay, it's said to be concave if for any x and y in the interval and for any alpha which is in the closed interval 0 to 1, f of 1 minus alpha times x plus alpha times y is greater than or equal to 1 minus alpha times f of x plus alpha times f of y. Okay, this is the concave function. Okay, next, problem 61. What is an exponential family? Okay, so why do we need to know what is an exponential family? Okay, let us see, search for it. Okay, exponential family. Okay, so exponential family first appears in the solution, which is the same solution that negative semi-definite appears in. Okay, so it is the solution to the problem, what is the maximum likelihood estimation. Okay, so let us go to here. Okay, so problem 61. What is an exponential family? Solution. Most of the commonly used distributions form an exponential family or subset of an exponential family, listed in the subsection below. Okay, that is, we will see some distributions in this subsection. Okay, the subsections following it are a sequence of increasingly more general mathematical definitions of an exponential family. Okay, however, due to the time limitation, I do not plan to introduce the subsections following these subsections. Okay, so if you want to see these subsections, okay, you can click on the hyperlink at the end of this solution. Okay, a casual reader may wish to restrict attention to the first and simplest definition, which corresponds to a single parameter family of discrete or continuous probability distribution. Okay, so let us see some examples of exponential family distributions. Exponential families include many of the most common distributions. Among many others, exponential families includes the following. Okay, so first is the normal distribution and exponential distribution and the gamma distribution. Okay, and the chi-squared distribution and the beta distribution. Okay, I think you have already learned what are these distributions in the course probability. So if you forget them, please review the textbook of the course probability. Okay, next, Dirichlet distribution. Okay, what is this distribution? Okay, you can simply search it on the Google and choose the Wikipedia. Okay, then you will see the Dirichlet distribution. Okay, simply speaking, the probability density function of the Dirichlet distribution of order k, which is greater than or equal to 2, with parameters alpha 1 to alpha k, which are greater than 0, has a probability density function with respect to Lebesgue measure. Okay, what is Lebesgue measure? Okay, due to the time limitation, I do not plan to introduce it here. Okay, on the Euclidean space R to the power of k minus 1 given by f of x1 to xk alpha 1 to alpha k is equal to 1 over b of alpha times the product from I is equal to 1 to k xi to the power of alpha I minus 1. Okay, where xk k is equal to 1 to capital K belong to the standard capital K minus 1 simplex. Okay, what is a simplex? Okay, let us go to the simplex. Okay, in geometry, a simplex, plural simplexes or simplices, is a generalization of the notion of a triangle or tetrahedron to arbitrary dimensions. The simplex is so named because it represents the simplest possible polytope in any given space. Okay, for example, a 0 simplex is a point. A 1 simplex is a line segment. A 2 simplex is a triangle. A 3 simplex is a tetrahedron. Okay, what is this? Okay, let us see. It is this object. Okay, and a 4 simplex is a 5 cell. Okay, what is a 5 cell? Okay, please see this figure. It is a 5 cell. Okay, so let us go back to Dirichlet distribution. Okay, or in other words, okay, summation I is equal to 1 to capital K, xi is equal to 1, and xi is greater than or equal to 0 for all I is in the set which contains 1 to capital K. The normalizing constant is the multivariate beta function, which can be expressed in terms of the gamma function. Okay, beta of alpha is equal to the product I is equal to 1 to capital K. Okay, gamma of alpha I over gamma of summation I is equal to 1 to capital K alpha I. Okay, where the bold alpha is a vector with elements alpha 1 to alpha capital K. Okay, this is the Dirichlet distribution. Okay, let us go back to the handout. And next, the Bernoulli distribution. Okay, I think you have already learned it in the course probability. Okay, and next, categorical distribution. Okay, what is this distribution? Okay, I do not put the data information about the categorical distribution in this handout. However, we can easily find it. Okay, in the use the internet. Okay, distribution. Okay. So let us see categorical distribution. Okay. Okay, in probability theory and statistics, a categorical distribution, also called a generalized Bernoulli distribution, multi-Nulli distribution, is a discrete probability distribution that describes the possible results of a random variable that can take on one of capital K possible categories, with the probability of each category separately specified. Okay, so we only need to know this. I think it is enough Okay. Otherwise, if you want to go to more details, okay, you can refer to this page. Okay, next, Poisson distribution and Wishart distribution. Okay, what is a Wishart distribution? I do not put the introduction to Wishart distribution in this handout. Okay, however, you can find the introduction to Wishart distribution. Okay, I recommend you to read the Wikipedia, okay, about the Wishart distribution. Okay, let us see the definition. Okay, because of the time limitation, I do not plan to plan to see this part. Okay, and we direct jump to the definition section. Okay, I think I can enlarge it. Okay, good. So definition: suppose G is a P by N matrix, each column of which is independently drawn from a p-varied mono distribution with zero mean. Okay, let us see. Gi is equal to Gi1 to Gip transpose, which obeyed the distribution NP of 0 V. Okay, so NP is the p-varied normal distribution. Okay, it means that is the multivariate normal distribution with p variables. Okay, then the Wishart distribution is the probability distribution of the P by P random matrix. Okay, S is equal to G times G transpose and is equal to summation I is equal to 1 to N Gi times Gi transpose, known as the scatter matrix. Okay. One indicates that S has that probability distribution by writing S obeyed Wp of Vn. Okay, the positive integer n is the number of degrees of freedom. Sometimes this is written W of Vpn. For n is greater than or equal to P, the matrix S is invertible with probability 1. If V is invertible. Okay, please note that V is also a matrix. If P is equal to V is equal to 1, then this distribution is a chi-square distribution with n degrees of freedom. Okay, this is the Wishart distribution. Okay, let us go back to the handout. And the next one is the inverse Wishart. Okay, what is the inverse Wishart distribution? Okay, again, I do not put the introduction to the inverse Wishart distribution in the handout. However, if you want to know more, I recommend you to read the inverse Wishart distribution article in the Wikipedia. Okay, please read the English Wikipedia. Okay, so we say X follows an inverse Wishart distribution denoted as X, okay, tilde W inverse of psi nu if its inverse X inverse. Okay, so X must be an invertible matrix, has a Wishart distribution W of psi inverse nu. Okay, so onto this point, okay, you only need to know this definition, which is enough. Okay, if you want to go through more details, okay, you can read this article by yourself And if you have any questions, please contact me. Okay, and finally, geometric distribution. Okay, I think you have learned this distribution in the course probability. Okay, it is 25 minutes. See you next time. Goodbye.